Welcome to Chips of Math Physics. In this video, we shall be looking at empty sets. If you are new to this channel, subscribe. Okay, assuming that we have two sets A and B, set A will be a subset of B if and only if every element in A is also an element of B. If A is the empty set, then A has no elements, because as the name implies, the set is empty. So if A is the empty set, then A has no element. And so all of the elements, there are none, belong to B, no matter what set B we are dealing with. And that is why we say that the empty set is a subset of every set. Let me prove that to you. So let's say, if possible, suppose that empty set is not contained in A. This is a sign for empty set. This sign represents not contained. So suppose that this empty set is not contained in set A. What this implies is that there is at least one element in this empty set that is not in set A, because we are saying that this empty set is not contained in set A. So it means that there are at least one element in this empty set which is not in A. But this contradicts the definition of empty set, because we know what empty set is, that an empty set is simply empty. It means that there is no set. But here we are saying that suppose there is an element in empty set which is not contained in A, and we know that there is no element in this empty set because an empty set is simply empty. So we can say that it is a contradiction of the definition of empty set, because by definition an empty set is simply empty. So now we can prove this by saying, let us have two empty sets. Let us have two empty sets. If we have two empty sets, let's say that we have empty set 1 and then we have empty set 2, and these are two empty sets. Since empty set is a subset of every set, because we are trying to prove that empty set is a subset of every set, it simply means that empty set 1 is contained in empty set 2. And if empty set 1 is contained in empty set 2, it implies that even empty set 2 is also contained in empty set 1. And if empty set 2 is also contained in empty set 1, This means that empty set 1 is equal to empty set 2. Hence, we can see this shows us the uniqueness of empty sets, which means that the empty set is a subset of every set. This is actually pure mathematics. When we try to prove that there exists only one empty set, and the empty set is a subset of every set, it looks confusing and contradicting, but that's why we call it contradiction, because we know we have only one empty set, and actually it is empty because nothing is inside. But for us to prove this, we must suppose that there is an empty set that is not contained in some set. And we know it is not contained in set because even that set is empty. This is exactly what we do in pure mathematics. And that is how you prove that there exists only one empty set, and that every empty set is a subset of every set. See you in our next video. Don't forget to subscribe to this channel. Galagash.